The mill is computer controlled, but with the rod moving at about 20 miles an hour, it still needs men to try to prevent the steel jumping out of its guide and causing what's known in the trade as a cobble. However, things do go wrong, and this causes particular problems at night when an engineer might not always be on hand to sort things out quickly. So they've installed an ordinary commercial micro to help diagnose faults. It's using what's called an expert system, which can be used by any inexperienced operator. The program contains a set of rules defined by an expert, in this case the steel mill computer engineer. In the middle of the night, when he's not there, the operator can call upon this system, which communicates with him in the language of the steelworks. The program asks him questions about the state of various pieces of equipment at the time when the fault occurred. And depending on the answers, it follows a particular line of investigation until the probable faults are identified. In other words, the program applies the expert's knowledge and his rules to help narrow down the reasons for the breakdown. In this case, a scanner head fault.
Well, that program wasn't written in BASIC because there's a better language, a better tool, if you like, for that type of application. You can use another language in the machine by loading it from disk or cassette, or maybe using a special ROM. For example, a language called microtext was used to write this program. Its main advantage is that it makes designing the screen format extremely easy. The expert in this case was a doctor, and it's a health diagnosis program which questions you about your lifestyle and, according to the answers you give, gives an opinion on your general health. Well, I've already put in some information about my age, my sex, my height, and my weight, and one or two other questions, and I've got to finish it off. Do you smoke? No. Can you eat more or less what you like without after effects? Yes. Do you take drugs? No. And that's about it. So we see what my general health is. At the moment, your general health is probably quite good, but your answers indicate that your health could benefit from a few simple changes in your lifestyle. Your answer suggests that you may be overweight. Carrying too much weight is not only unattractive, but can also increase your susceptibility to some types of disease, notably heart and circulation problems. Well, of course, the opinion it gives is only as good as the person who sets the questions, the expert, and it's quite clear to me that in this case, he got it a bit wrong. Well, this program behaves in a totally predictable way. It's not learning as it goes along. And perhaps the most exciting area for the future of computing lies with programs that are able to learn. And we've got one here. This is a program called Animals, which is a type of 20 questions game. The computer has a set of questions and possible animals stored in its memory, represented by this tree of possible routes. At the moment, we're at the base of the tree at this point here. And we've got the first question, is it a mammal? And depending on the answers, it will go up one or the other of the branches on this. Well, in this case, I've chosen zebra. Is it a mammal? Yes. Does it have stripes? Yes. And it's going up the yes branch. Is it a carnivore? No, it goes up the other branch. And it's come to the end of the tree, or the top of the tree. Is the animal a zebra? Yes. Well, it got it. But the most interesting part of this is when it gets up to the top of the tree and it hasn't got the answer that you've predicted. So I'm going to play it once more, and this time I'm going to choose a robin. Is it a mammal? No. And it goes up the other branch. Is it a bird? Yes. Does it fly? Yes. And it's gone right to the end, or the top of the tree there. Is the animal a duck? And it's only got one flying bird, and it's not a duck. No. Well, it gives up. What is your animal? Well, my animal I've chosen is a robin, so I'll type it in. Robin. Give me a new question. Well, a fairly simple question. Does it swim? What would the correct answer be for a robin? Well, at this point, we're right up at the top of the tree at this point here. And what we're going to do is to replace this end point with a new question. And the question is, does it swim? And as I hit that, two new branches come up, one of which will be robin, and the other one will be the duck. So I can try it again. Do we want to play again? Yes. Is it a mammal? No. Is the bird? Yes. Does it fly? Yes. Does it swim? And we're right at that point there. No. And there it is. Is the animal a robin? Yes. I got it. Want to play again. Well, of course, this program's very limited because it can only go further and further into the tree. It can't use two answers to infer a third, for example. For that, it would be better to use a more sophisticated artificial intelligence language. But it's not only possible to teach the computer new facts, but also a complete sequence of tasks. Our researcher, Catherine Robbins, has been using an artificial intelligence language to talk to a robot.
Base. No. This robot arm is being controlled by a high-level language which recognizes spoken instructions corresponding to the various parts of the arm. Its wrist, its shoulder, its elbow, and so on. Elbow. Hand. Before I can actually get the arm to move by using these instructions, I've got to teach the computer to recognize the pattern of my voice for each of the keywords which I'm going to use. Wrist. Well, now that the machine has learnt to recognize the sound of my voice, I'm going to train the arm to pick up a beaker. The instructions I give the machine will be stored as a single routine. Shoulder. Yes. I can use each instruction to make the arm move a precise amount in any direction I want. Elbow. Yes. Eventually, I finish giving it all the commands necessary to make it complete a routine. In this case, that's reaching over, bending down, and picking up the beaker. Quit. Yes. Once the routine is completed, the arm is then reset. Well, having taught the machine a routine, I can now call up the sequence whenever I like. In this particular sequence, we've called beaker for the sake of argument. So we'll see whether it works. Beaker. And away it goes and starts to work. I could also teach it other routines, such as put and box. Then it would only be a step away from understanding a complete sentence. Put beaker in box.
Well, that's a very nervous-looking robot. Next week, we'll be getting our own robot, the BBC Buggy, to appear to do intelligent things. And we're looking at how we can link the computer to the real world, sensing what's going on and controlling equipment. Is that all it does? Well, see you next week.